Okay, welcome back. Day 2, week 4. Today we're going to continue with the same topic, equations with two variables. We had one example and we graphed that example. Today we're going to graph another example using this table, and we're going to see two particular situations that do not require the input-output table. Okay, so I'm going to move this to a side, and we're going to place today's date at the very top of the notebook. Remember, since it is the same topic, there's no need to place the topic again. Today is January 25th, 2022. And what is our exercise? Today exercise is going to be y is equal to -1/2 of x plus 4. So that is our equation. What are we going to do? We need to draw our input-output table. So I'm just going to do it right over here. I'm going to erase this text that I have over here so I can have enough space. And I'm just going to leave 3 columns, okay? Just the 3 normal columns that I'm supposed to be working with. So this is y, x, sorry, and this is y. And what is the domain that I'm going to use? Remember, the domain is the same. -2, -1, 0, 1, and 2. So I'm going to begin with -2, and I'm going to go step by step. So I need to substitute the values that of the domain inside the equation in the middle column in order to find the value of y. So I'm going to say, okay, y is equal to -1/2, and instead of x, -2 plus 4. Now remember, when we have a fraction that's multiplying another fraction, I multiply in a straight line. Some of you might say, but Nice, -2 is not a fraction. Then we make it a fraction. How do we make it a fraction? With a positive 1, indivisible 1 as a denominator. And then we're going to multiply in a straight line. Okay, so we are going to have that y is equal to -1 times -2.
-2.
-1 times -2.
+2.
+2.
Positive 2.
Yes, +2. 2 times 1. 2 times 1.
2.
Correct. 2 plus 4. Now I can simplify this 2/2. How much is 2/2?
1.
1. So I have that 1 plus 4 is how much?
5.
5. That answer is the one that I'm placing over here. Okay, so for this one, it was 5. Now we go with -1. Again, y is equal to -1/2. And instead of x, -1 plus 4. Again, we place an invisible 1 because we need to have a fraction since we're multiplying fractions. Okay, and we're going to have y is equal to -1 times -1. +1.
Sorry.
2 times 1. 2 times 1. 2. 2. So 1/2 plus 4. So what should I do in this case where I have a fraction that's adding an integer? Well, the same thing that I did over here. I'm placing an invisible one. And remember, we have different ways of adding fractions. The easiest one or the most used one is the happy face method. So that's what I'm going to do. I'm going to use the happy face method. And I'm going to say that y is equal to 1 times 1,
1.
1 plus 2 times 4, 8 over 2 times 1,
2.
2. Now, y is equal to 1 plus 8,
9.
9 over 2. Can I simplify 9 over 2? All right, so that's the 9 over 2 that I'm placing over here. Some of you might say, Miss, and how are we going to grab that 9 over 2? Then just for this, just for the graphing purpose, we're passing this into a decimal. So 9 divided by 2 will give us as a decimal 4.5. Okay, so just for the graphing purposes, we're placing a decimal. Okay.
So it'll be 4.5 over 1.
No, 4.5. That's it. When you pass 9 over 2 as a decimal, it is 4.25. Okay.
Okay.
We don't place it again as a fraction. We leave it as a decimal. Okay, now we go with 0. So y is equal to negative 1/2. And instead of x, 0 plus 4. But anything multiplied by 0 will always be
0.
0. So I can cancel this out. And what do I have left? Only the 4. So y is equal to 4. And that's the 4 that I'm placing over here. Then I go with 1, positive 1. Y is equal to negative 1/2 times positive 1 plus 4. And just like we did over here, I'm adding an invisible 1. And I'm doing the multiplication in a straight line. Remember, multiplications are in straight lines. And I'm going to have that y is equal to negative 1 times 1 negative 1 times 1, negative 1, correct. And 2 times 1, 2. So plus 4. And again, I need to have this as a fraction, this 4. So I'm adding again an invisible 1. And just like we did in this negative 1, we're doing the happy face method. Okay. And what do we got then? We are going to have y is equal to negative 1 times 1 negative 1 times 1
Negative 1.
negative 1 plus 2 times 4 8, that's a really awful 8, over 2 times 1, 2. I'm going to place it over here. Negative 1 plus 8. Negative 1 plus 8.
8.
Negative 1 plus 8. Different signs. I subtract and I keep the sign of the greatest number. So 1 minus 8 minus 1 is 7. 8 is greater, so it's positive over 2. Can I simplify 7 over 2? All right. So I'm going to place 7 over 2. But again, for the purposes of graphing, I'm passing this into a decimal. 7 divided by 2 is how much? 3.5. 3.5. What can you notice? Got 5, 4.5, 4, 3.5. What can you notice in there? Is there a pattern in there? There is a pattern. So let's see. Now we go with 2. So y is equal to negative 1/2. And instead of x, positive 2 plus 4. I add the invisible 1 and I multiply in a straight line. Negative 1 times 2.
Maybe we have to blow this to excluir.
Sorry?
We have to blow this to excluir.
No.
Okay.
Okay. But you do need to have it in your notebook because it's going to help you solve the next exercises. Okay. Hurry up. Negative 1 times 2. Negative 2. 2 times 1. 2 plus 4. Negative 2 divided by positive 2. Because we're simplifying this. Which is negative 2 divided by 2. Nope, it's not 2. How much is it?
Negative 1.
Negative 1. And negative 1 plus 4.
3.
Positive 3. That's the number that I'm placing over here. Okay, so let's have it there because we're going to graph it now. Now we need to graph it. So I'm going to graph it over here. I'm drawing my coordinate plane. It doesn't have to be that big. Okay, it might be a little bit smaller according to the numbers that you need. Remember, we need to place the arrowheads in the coordinate plane always. That's really important. This is X. And this is Y. Okay. Now, what are we going to do? We're going to graph. I'm not placing no more numbers than the ones and the negative ones. Okay, the little lines. You can place them if you want. If you don't want, you don't place them. Positive 1 and negative 1 of the Y. Positive 1 of the X. And negative 1 of the Y, of the X. Okay, so negative 2, this is negative 2 on the X, 5 on the Y. 1, 2, 3, 4, 5. Right there. Negative 1 comma 4.5. Since this is a decimal, then yes, you can have the point right in the middle of the little square. So 1, 2, 3, 4, and 4.5 is between 4 and 5, so it's right in the middle in there. 0, 4, it's right on top of the y-axis. 1, 2, 3, 4. 1, 3.5. 1, 2, 3, and right in between the 4 and the 3 is 3.5. And 2, 3. 2, 1, 2, 3. And I connect that with a straight line. I should be using a ruler. So let's try and see if I can. Yep, I did it. Very good. Sometimes my coordination in this is not that good. And that's it. That's your graph. Do you have any questions so far? Okay, so let's go with the next one. Next exercise, we're gonna graph it down here. Next exercise, I'm gonna graph both two exercises in one coordinate plane, but you need to do it separately, okay? If I say y is equal to 2 or x is equal to -4, for example, I'm gonna graph both of those in the same coordinate plane. I'm gonna graph this one in blue, and I'm gonna graph this one in red, okay? So what are you going to do when you have that? Well, you need to be careful on how you graph it. Since there's only one variable, y equals to 2, I only have the variable y. I don't have no other variable. I don't use the input-output table because I only have one variable. So I don't use the input-output table. I just go ahead and graph. Okay, but what am I gonna graph? Let's begin with this one, with y equals to +2. So where is +2 on the y? It's 1, 2 over here. Basically, this is like saying 0, 2. Okay? Basically, this y equals to 2 is like saying that the order pair is 0, 2. So that's the point that I graph. But I told you, we need at least 2 points to graph a straight line. At least 2 points. We can have more than 2 points, but I need at least 2 points. But I don't only have one in there. So what does that mean? What does that y equals to 2 mean? Well, it means that the first point is 0, 2. Always 0, whatever value of y you have. But it also means that it will take into account every single order pair of your coordinate plane that has y equals to 2. Like for example, 1, 2, or -3, 2. Okay, any point that has the second coordinate 2, then that would be part of this line. So in other words, this is the straight horizontal line that passes through every single point that has the coordinate y equal to 2. So you don't need to draw these points, okay? You don't need to graph those points. You can just go ahead and say, okay, it's 2, and boom, you draw a horizontal line in there. So that is y equals to 2. Are we clear with this? Yes? Same thing goes with x equals to whatever number. It means that it's going to take into account every single order pair that has the first coordinate equals to -4. So in this particular case, this first point will be -4, 0. Remember, if I give you the value of x, the value of y is going to be 0. If I give you the value of y, then x is going to be 0. So in this case, I have -4. So -1, -2, -3, -4. And I'm going to graph a straight vertical line that passes through every single point that has the coordinate 4, -4 of the value of x. Now, you see, 2 different types of graphs, actually 3 different types of graphs. Question, is this graph a function? Is this a function, the green one?
Yes.
Yes, because if we pass a vertical line, it will touch only one point throughout the graph. Is the blue one a function? Yes, right? Because if I pass a vertical line, it will only touch one point at the same time. Well, now, is the red one a function?
Yes.
Okay, let's use the ruler and let's see if it's actually a function. Okay, ruler. Let's place it completely vertical. Okay, so the blue one, it goes only 1 point, 1 point, 1 point, 1 point. Now let's see the red one. How many points am I touching in the red one?
1.
I'm touching the whole line, right?
Yes.
Okay, what does that mean? Now remember, a line is a group of points. So 1, 2, 3. If I go and place a lot of points, one after another, what do I get? I get a line. So it means that this,
Entonces no es una función.
sorry?
No es una función.
It is not a function, exactly. So remember, vertical lines are not functions. Horizontal or inclined lines, they are functions. But in this case, the red one is not a function. Not function. But the blue one and the green one, they are a function. And if they're functions, are they also relations? Yes, right? If they're functions, they're also relations. And if they're not functions, are they also relations? Is this one a relation as well? Is this a relation, even though it is not a function? Yes, it is a relation. Remember, every function is a relation, but not every relation is going to be a function. In this case, this is a relation that is not a function. Do you have any question whatsoever? Okay, then. So basically, this is what we were going to graph for today. Now, what are we going to do in our next class? Like I told you, we are going to work in a little classroom. But one more exercise and we finish, okay? What happens if I give you an equation that is negative 4x plus y equals to 16. As you can see, this one has a variable y completely alone. This one does not. So what should I do in that case? In that case, I need to solve for y. In other words, I need to leave the y positive and completely alone. Okay, so that's what I'm going to do. This negative 4 is going to go to the other side with an inverse operation. If it was negative, it goes positive. So I have now that y will be equal to 16 plus 4x. And now that I have the variable y completely alone, I can go ahead and use the input-output table to graph this linear equation. Questions? No questions. We're good. Okay, then. This is the topic for today, or the practice of the topic that we saw yesterday.